Now we're going to do some more examples of rates of change and unit rates. One of the important things to note is how are things equivalent? In the math world, it's a very important word. It says look it up and discuss it with your group. It means one thing is the same as another, even though maybe they don't look exactly the same. So let's start with this example. If you make $100 a day for doing a particular job, how much money would you make in a 5-day work week? Well, notice that what this rate here is $1 per 1 day. And so if we take that value and multiply it by 5 days, we'll be able to calculate how much you make for that entire 5-day work week. Notice these days cancel, doing our unit analysis, and we're left with $500. Well, our author says, are these two things equivalent? $100 for 1 day, is that the same as $500 for 5 days? And of course they are, right? So if I simplify this fraction, 5's cancel, and we're left with $100 over 1 day. So they are the exact same thing. In mathematical terms, this is exactly equal to that. Even though they have different numbers, it's because of the common factor of 5 that we can divide away. Okay, so let's look at this another way. Here we've got 60 miles divided by 4 hours. So a change of 60 miles divided by a change of 4 hours. And our author says, hey, let's get a 2 in the denominator. Well, to be equivalent, so we're going to put an equal sign in here. And to preserve that, if we divide the bottom by 2, we must also divide the top by 2, by the exact same number. So this gets us 30 miles divided by 2 hours. That is exactly the same as 60 miles divided by 4 hours. Now, this might bother you. He has us do it down here now. He says, well, now let's get a 1 in the denominator. So here we could have divided by 2 again, or we could go back to our original one and said, why did you choose 2? You should have divided by 4, right? So that gets us 1 hour over 15 miles. So this number is a unit rate, and all of these others are just rates, some sort of rates of change. Again, the key point to a unit rate is the denominator is 1. Okay, so here we're to write a fraction equivalent to 320 divided by 4 days that has a 10 in the denominator. What? Now he gives us a hint. First scale down, then scale up. So we can't add things to the bottom and the top. That does not preserve equality. That changes the values in the fraction. So we can only multiply or divide to make our changes, which is why our author suggests let's scale it down. Well, notice both of these things are divisible by 2. So I'm going to divide by 2 and divide by 2 for the top and bottom. Let's see, the top feels like a solid, what, $160? $160, and the bottom is, oh, that one's a little easier, 2 days. Now here's why I chose that. If I'm trying to get to 10 in the denominator, now that I have a 2, I know that 2 times 5 is 10. So if I multiply the bottom by 5 and then the top by 5, I've got what our author asks us to do. I've got a 10 in the denominator. Let's see, 5 times 0 is 0, 5 times 6 is 30, so carry a 3, 5 times 1 is 5, plus 3, that's $800 per 10 days. Now, to be honest with you, I can't think of a time when this would be super useful. Mostly we like to think about unit rates. How much per one of these things? All right, so we got one more here. If one bicyclist is pedaling at a rate of 40 miles in 3 hours, let's pause there. That's a rate of change. They're traveling 40 miles over a time span of 3 hours. And another is at a rate of 50 miles per 4 hours. Who's faster? Okay, well, excuse me, you might know that you can't compare fractions directly when their denominators are different. So we need to get the same denominators. And I think the easiest one to do is just convert these to unit rates. In other words, how much distance are each of them traveling in 1 hour? Because then we're comparing the same deal. So how do we do that? Well, we just divide the 40 by 3 and the 50 by 4 and get that approximation. So 30, oops, we said 30. 40 divided by 3, that's 13.333 repeating. So I'll write that as the 13.3 repeating. And then 50 divided by 4, that's 12.5. Let's make sure we get our miles on there. And you can see that the first person, this person is the fastest. So 40 miles per 3 hours is biking faster. How does that sound? He says scaling down or scaling up could be useful. The other thing we could have done is noted that we could see how far would each travel in 12 hours, and then we'd have the same denominator. But I think scaling down is maybe the most useful in this case.